So we understood that atoms are made up of blah 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 blah, and electrons occupy a particular space, and they are of particular shape, and they occupy in a particular order. And all of this put together makes up a periodic table. How they behave and so on and so forth. Right? All of those factors put together makes up a periodic table. Now we are looking at actual reaction. End of it, that's what we are going towards, is it not? Why do chemical reaction occur? That's the most fundamental question that we can ask. Because atoms want to become more stable. They want to be more stable. Okay. Now, so atoms want to be stable. How does they get to be stable? Stable as in they don't want to react more, as simple as that. How do they get to become more stable? By achieving the electronic configuration of noble gas, a full outer shell, usually following the octane rule. Okay, so basically, yeah, this is your noble gases. They want to be this or have a configuration which looks like that. So basically, for example, you can see over here 2p6. Remember, p can accommodate up to 6 electrons, and this is a stable configuration. This too is a stable configuration. This too is a stable configuration. Okay, guys. 3, 10, because 10 D can accommodate 10, right? So this is a stable configuration. So basically, elements other than the noble gas, right, everywhere else, including this actually, they want to go towards being this. This is a general thumb rule. Okay, guys, there are many exceptions that I won't be able to discuss now, that you guys will be getting exposed in time. But to begin with, this is the answer. They want to be stable, and how do they get to be stable? By having the electronic configuration that is similar to that of noble gas. That's the simplest answer that you can have as of now. Now, how do atoms that are not noble gas achieve stability? Right? We understand how they want to be stable, and how does stability look like, but how do they actually achieve it? What do they do to achieve this? Well, simple. They can do one thing. They can handle electrons. They can take up electrons, they can lose electrons, or they can share electrons. Thus, filling up the outermost electron or emptying it and becoming stable. See, the number of electrons is what makes it unstable, basically. Right? So, what do? Either they give it off or they take in, so that they become that noble gas configuration. Right? That version of stability. Now, please explain more about losing, gaining, or sharing with shell, subshell, and orbitals. Right? Let's understand with that perspective, with our basics. For example, chlorine. So let's look at where is chlorine. Chlorine is, yeah, here. It's just one step away from a noble gas. So let's see what happens. Chlorine has 1s, 2s, 2p, 3s, 3p, 5. Right? The noble gas is next to it, which has a configuration of 3p6. So what do you think chlorine will do? Don't read anything, just think about it. Chlorine has 3p5. The closest neighbor, not most neighbor, the closest neighbor that the chlorine has is 3p6. So chlorine will, yes, they will gain one electron to become stable. Let's look at sodium. Sodium will be here, right? And its configuration is 1s2, 2s2, 2p6, 3s1. So here we are. A step back is what we have, and now this is over here. Remember, obviously, atoms will not see periodic table. Remember that. They don't have periodic table. It's us who has created that. So for sodium, the closest atom is this noble gas with 10 as its number of electron in it. Now, what will sodium do? Technically, it wants to do this. It wants to go to this. And this is what it has. What will it do? It will lose an electron. Okay, guys. Last example, last scenario, oxygen. Oxygen configuration is 1s2, 2s2, 2p4. Right, so oxygen is somewhere over there, yeah, over here. Helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, right? It's over here. Now, oxygen has this particular configuration. It shares 2 electrons with another oxygen to form O2. So basically what it does is, it will talk to other oxygen. It will tell, we will share 2. This results in both atom achieving a electron configuration of this particular, will have this particular configuration, mimicking the stability of neon, right, over here. So it will share, say, I mean, of course, oxygen reacts with other things as well. But if it has to react with something, for example, another oxygen, this is how it looks like, O2. So it will share 2 electrons. How does it look like and all of that? That we'll be seeing in time, but this is the basic idea. Again, why do chemical reaction occur? Because atoms want to be more stable. So what does stability mean for them? To have a configuration similar to that of a noble gas. Again, this is a thumb rule for most of the case. So that usually means octane rule. So basically the last shell will have 8 electrons is what it means. That's why it's called as octane rule. For example, 2s2, 2p6. This makes up a shell, and we can see that they add up to 8. This 2 adds up to 8. 5s2 and 5p6 adds up to 8. That's why it's called as octane rule. Again, it's usually that. It's not all the cases. We're not going to look at that though. Other exceptional cases, quite a few. How do atoms that are not noble gas achieve stability? They do this. They lose, they gain, they share. And it should make sense. Who loses, who gains, and who shares. That too is, fixed by, not fixed actually, it's commonsensical if you understand which atom is where. Chlorine is 1 away, right? Chlorine is 1 electron away. So it wants to gain. Now it's much easier to gain than to lose. Sodium, it's 1 step ahead. So it will lose. Oxygen is somewhere in between. So it is like, chalo, we'll share it. No, with another oxygen, it will share. Again, oxygen reacting with quite a few other things. The scenario will be different, so on and so forth. We're not discussing that. It's just a simple example. Okay, guys.